All right, welcome everyone. As far as announcements go, we have our last quiz of the semester this Friday, available this Friday until Monday. So there's a practice quiz available for that here on Canvas. That's going to cover some of the linear regression we've covered up through today, as well as some chi-squared goodness of fit, chi-squared test of independence, and some method selection for some of these methods we've covered in the second half of the semester. So please give that practice quiz a try so you can ask questions about it on Thursday or Friday if you'd like. Are there questions about the homework? Allison. Homework 27, problem 2. Good. Yeah, so we haven't talked about how to do these problems yet. So if you haven't watched the video for Friday yet, don't worry, but this will be a sneak preview. We are trying to find the expected net winnings, where net winnings means after we account for the price of a ticket. So the way to do this, I'll start a fresh document in Word, is to use L1 and L2 to create a table. So here we can let L1 be the prize and L2 be the probability. So let's see. We have a grand prize that's worth $14,500. I think your numbers might be different than this, so be careful. And a second prize worth $1,500. Don't forget about the possibility of not winning, which would be a prize of $0. And then the probability of each of those. So there are 11,400 tickets sold. So the probability of winning the grand prize would be 1 out of 11,400. The probability of the second prize would be 1 out of 11,400. And the probability of winning nothing would be 11,398 out of 11,400. So you want to make sure that the probabilities add up to 1, because the probability of something happening has to be 1. And then to find the expected prize value, that's going to be the mean prize weighted by the probabilities. So here's where we're going to use the one variable statistics again. And here's where you're actually going to use the frequency list. So you'll either do L1 as your main list, and then L2 as your frequency list. Or if you have an older style TI-83 that doesn't give you like a menu to put in the frequency list, Then you would do one variable statistics. Oops. L1, comma, L2. This is what my calculator does. That's all. Nettie, did you have a question related to this?
Yeah,
Cool.
so what is the frequency list? And like, is it better than the other calculators?
So the frequency list is you're putting in the frequency or the probability associated with each of the rows in L1. So mostly we haven't been using that this semester because we've just been putting in L1 one number for each time that number occurred in the data set. And like technically we could do that here if we put in one copy of the first and second prize and then 11,398 copies of the zero. But we wouldn't want to do that because that would be a lot of typing the number zero. So the frequency list of the probability lets us do that without all that typing. Does that answer your question? Cool. And then from this one variable statistics, then just look at the mean. So look at don't remember if it's going to call it mu or x bar. So what that's doing is it's finding the average value of the prize weighted by these probabilities. And really that's the same as saying, take the value of each prize times its probability and add them up. So you'll get the same answer both ways. Doing it this way will give you the average prize value. Then to get the expected net winnings after you account for the price of the ticket, take that answer and subtract $5. Alternatively, we could have just subtracted $5 from each prize value as we were entering it into L1. Allison, does that answer your question?
Yeah.
Cool. Other questions about the homework? Mary. Homework 25, problem 9. Okay, so we have the distance of planets and their orbital periods. And any particular part of this one?
Just C.
Part C. Sorry, what? All right. Yeah, do you have the equation handy?
It's
704. Cool. All right, and check that I entered those incorrectly. Looks good. All right. So what is a residual? Like, how does it relate to y and y hat? Yeah, so observed y minus predicted y. So here the observed y is the actual orbital period of Earth, which is 1. So we have 1 minus the predicted y. And then we need to find the predicted value of y. So we can do that by taking Earth's x value. So its distance from the sun is 149.6. Mary?
Thank you.
Okay. Other questions about this problem? Judah, should we finish this one? Sounds good. So we're taking this 149.6 and plugging it in for our x. Scoot. So because I just have the formula written out here, it's not on my calculator, I'm going to go ahead and multiply 149.6 by my slope. So use Google as a calculator. So 5.385, and then subtract 8.79. So negative 3.408. No, didn't like that. Nope, thank you. That was dumb. All right, so 1 minus parentheses 4.408. There we go. There we go. So the other way you could do this, if you have this equation from part B in your calculator, would be to look at it in your graph and then do second trace to get to calc, and then enter in the value of x equals 149.6. And your calculator will jump to the height of the line at that x value, which is the predicted y value according to the regression line. So that can be a shortcut, so you don't have to type in all of the numbers in the slope and y-intercept in order to plug 149.6 in for x. Here, so does that address your question? All right. Other questions about the homework? Allison.
Can you do homework 27, problem 3, just part B?
Homework 27, problem 3B. Okay. So the probability of F, or the are events E and F independent?
Just like how to find the probability of that.
Okay. So I got F as the difference of the numbers is 3 or more. Does that agree with what yours was? All right. I think this one has a couple different events that it can use. So one way to do this is to look at a table of possible outcomes of dice. I think there might be one in the hint. Yes. What? That's not the same. All right. So dice sample space. All right. So I just Googled 2 dice sample space and got this. So this is laying out if the first die is 1 through 6 and the second die is 1 through 6, here are the combinations. And then you can go through and count which ones have the difference of the numbers is 3 or more. So let's see. We've got these 3, 1, 4, 1, 5, 1, 6, 2, 5, 2, 6. So that 3 plus 2 is 5. 3, 6 makes 6. And then we have sort of the mirror image down here. So like 4, 1 instead of 1, 4, 5, 1 instead of 1, 5. So we had 6 in the upper right-hand corner and 6 in the lower left-hand corner out of 36 total possible combinations. So that the probability of that is 12 out of 36. All right. Nettie, were you raising your hand a moment ago?
Yeah, could you go over number 25, problem 9, or sorry, 10, and the last part of it?
Problem 10. Okay, so this is using the performance on a verbal ability test to predict the final grade in a psychology course. And here we're deciding whether regression should be used to predict the final grade of a student with a verbal score of 100. And this is admittedly a little bit silly because we're taking this thing that really should be like a short answer question, like explain your answer and condensing it down into just say yes or no. But the thing to look at here is how 100 relates to the verbal scores in the data. So in this data set, looks like the highest verbal score was 74. So that means that a score of 100 is far outside the range of the verbal scores that we use to build the model. Anybody remember what that's called when you're making a prediction outside the range of the data? Extrapolation, yeah. So when we make predictions using extrapolation, those are less reliable than predictions that are inside the range of the data, essentially an interpolation. Because it might be that there's a linear trend in this range of 29 to 74, but then after that, the trend starts to curve one way or the other. So in this case, we probably don't want to use this linear model to make a prediction for someone with a verbal score of 100 and then rely on it. Like we could make the prediction, but we probably would not want to rely on it because it is significant extrapolation. Any questions about that one? All right, so let's leave the homework questions there for now, because I want to make sure we have time to talk about our activity from last time. So last time we looked at this data set of recycling and home values. And let's skip down here to the regression equation. So we have our predicted Y value. So this is going to be the predicted percentage of households who recycle. What did you get for the regression equation? Mary, what'd you get?
0.000029036162.
Did I get the right number of zeros? 5 zeros, all right.
61.
All right, so this is times X plus
0.23731.
for the Y-intercept.
Yes. Yeah. 0.237.
Was there a number before the decimal?
No.
Oh, interesting.
Oh, we did like, or could we do 3.731? Maybe we just didn't put it that way.
I thought, didn't other people get like 53 something for the Y-intercept?
We had 23.721.
23.721? Okay, all right, so we're on board here.
It's only supposed to be 3 zeros.
And Brady, what was your slope that went with the 23?
2.9036 times 10 to the negative 4.
Times 10 to the negative 4, so 3 zeros we got here. Awesome. So what is the difference between these two equations? Brady, what was your units for the percentage of households who recycle? Like, how did you enter those numbers in?
I think we put them in as like just whole numbers, not percentages.
So this is using the percent as a number between 0 and 100.
Yeah.
And Mary, what did you do? How did you enter in your percentages? Using the percent as between 0 and 1. Cool. Did anybody get anything different? Without making a typo. So both of these are correct. It's a matter of what your units are. So this makes sense that if your percentage is a number between 0 and 100, that, what's the deal here? As you increase, like a $1 increase in the home value has a bigger impact on the percentage if it's a number between 0 and 100 times bigger, than if the thing that you're predicting is a decimal between 0 and 1. So really these equations are saying the same things, just the numbers in the second equation are 100 times bigger than the numbers in the first equation because the Y values were 100 times bigger. So that's going to make a difference in how we then interpret the slope of the regression equation. So what is our interpretation going to be for every something, something? Nettie, what'd you say?
For every $1 increase in home value, recycling goes up 0.00904.
You were using the decimal or the number between 0 and 100?
I was using the decimal, but then I think I switched.
So if we do this in terms of the decimal, let's call this the proportion to try to make it more clear that this is between 0 and 1. The proportion of homes that recycle. Increases by the slope amount. And we want to do something to remind our readers that this is not a hard and fast rule, that it's the observed proportion of homes that increases. This is something that's on average or expected or predicted. So we could say the predicted proportion of homes that recycle increases by the slope amount. If we're thinking about the percentage as a number between 0 and 100, then we could say for every $1 increase in home value, the predicted percentage of homes that recycle increases by the slope from that version of the equation. And I'm going to say percentage points. So I like to say percentage points here in order to try to clarify that this means this is how much we're adding to the percent, rather than like if your salary increases by 10%, if you were earning $100, that's a bad example. If you were earning $50 and you increase by 10%, you add on 10% times the $50. So your salary becomes $55. So instead of saying the 0.0002%, by saying percentage points, that's trying to emphasize that this is, we're adding an amount to the percent. We're not increasing the percentage by multiplying it by something. Questions about this interpretation of the slope? Key points here are we're always going to have a, for every 1 unit, so in this case, dollar, increase in the explanatory variable. The predicted or expected or average Y value increases by the slope amount. Last time, table 2 pointed out that this is a really small amount that maybe makes it look like home value doesn't have much to do with recycling. But you need to pay attention to the fact that a $1 increase in home value is a really small increase as well. So in order to get a better sense of what is the effect of, or what is the relationship between home value and recycling, it might even be better to write this interpretation in terms of for every $1,000 or $10,000 increase in home value, how much do we expect recycling to increase? To get a better sense of sort of the scale of these numbers. All right. So then, is it reasonable to interpret the y-intercept? Let's do thumbs up for yes, thumbs down for no. So thumbs down, tell me why it's not reasonable to interpret the y-intercept in this case. Mary?
No, because houses don't have a value 0, so it wouldn't be recycling, or like if it's a value 0, there's no house. So there's no
Right, so the y-intercept is our prediction of what the recycling percentage would be in a city that had a median home value of $0. And it's not reasonable to think of a city that would have a median home value of $0. That wouldn't be a city. So in this case, it's not only extrapolation, but I think it also doesn't really make sense as even an unreliable prediction. All right. Computing St. Paul's residual. So that's similar to the homework problem that we just did. We have the observed Y value, which is 70.9. Minus the predicted Y value, which you're getting off of your calculator. You can use the second trace to do the calculation. And finally, what proportion of the variation in the recycling participation rate can be explained by a linear relationship with home value? Someone got a number for us? Nettie, what'd you have?
0.2827.
0.2827, does that agree with what other people got? Yeah, or if we wanted to write it as a percentage, 28.27%. And Nettie, what were you looking at in order to get that?
R squared.
Yeah, that's our R squared, our coefficient of determination. So in this case, it's not a lot of the variation, but it's pretty good for trying to predict recycling rate with just a single variable. If you think about the number of things that probably go into affecting the recycling rate. Any questions about Monday's activity? All right, ready to charge ahead into the activity for today? All right. Hang on. Which video did you watch for today? I might have printed out the activity for tomorrow.
Linear regression.
Simulation.
Using simulations.
Yep.
This is the activity for tomorrow. Yeah, sorry about that.
I wrote my first one was hypothesis.
All right, I'll bring this up on.
It's like election. It's like.
So gotta look at my course schedule from last year to remember what the name of the file was, and then I can go find it. Come on.
I don't watch it. But I kind of like it. It's just like, like, I feel like if I were to watch it, it's not too bad. It's kind of relates.
Exam times. There we go.
I'm what type of- It's all like the hypersensitivity.
Oh. Yeah, I feel like there's a lot. I mean, there's so many more
Like type 1, type 3, type 4, here in the skin. And type 2.
Yeah.
All right, so we are working on this exam times activity, which is on Canvas, and I will give you access to the computers so you can open it up on your computers to answer the questions there. Sorry about that. At least I have the printouts for tomorrow all set for you.
Are we submitting these?
So I'll come around and check your notes and mark down that you're here, so you don't need to submit these online. But you may want to type your answers into the document online so you have a record of what we've done. Otherwise, if it's easier, you can sort of write your answers in your notes, and then you'll be able to relate it to what's on Canvas as you're studying. All right.
Birthdays? Yeah, New Year's? Oh my gosh. I love Gemini. She's a thing, there's
Man.
The amount of time.
Hey, what is it again?
The amount,
Start assignment.
the amount of time a student spends on
So you have to turn it. You turn it.
Yes. Right, I don't know, do we?
these. No,
Okay.
but it's just for your homework.
So not actually. That was just the types of the test.
Looking at it, you did it, but then-
I'll ask. I said, I was just type in the comments response here, will show you the score.
Yeah, exams.
I'll see the picture more thing.
Oh,
That's gonna be.
Wait, so they explain for you?
Yeah, I know how to process.
No.
We're not saying the response is the amount of time. Like response, let's say it's self-reading stuff, like, oh yeah, like.
What you spell wrong?
I did.
You have the two spaces. See what it says.
Like the corrections.
Parking is a space.
Yeah.
I didn't do.
I didn't see it. Okay, what is the response?
Exam score. Alright, go hypothesis and words and symbols.
Alright, so simple, it's just that.
On B. How do you get the, like, alright,
Alright, now let's talk.
yeah, Greek letter there. Oh, I guess it.
Oh, yeah.
There you go. Well, thank you.
Oh, what mine?
Are we turning this in?
Slash go to.
Oh.
No, we're not.
No,
Oh.
because you're here, you don't need to turn it in.
Oh, okay. I was like, so I was just gonna submit a picture after.
So you might want a version of the answers for yourself.
Yeah, I'll take a picture.
Okay.
Yeah, I was just waiting for me to submit.
Wait.
Backslash E. This is there.
Oh.
And then
I was
enter
doing-
space.
I kind of find this.
It's, uh,
Oh, I'm not in the equation this time.
Data. There.
Oh. Yeah, I'm just saying.
Is there an association?
If there isn't, it's not. Because you can probably name association with any association. It's not.
Yeah, so. Is there an
Yeah.
association, so it could be positive or negative?
Or the alternative.
Yeah. What is it? What is it?
Wait, do you have written? Go ahead. That's for stuff.
Yeah.
This one is like. Well, it would make sense to write two sentences. They all start on.
Okay. You say so.
There's no association.
Or zero. Alright, and then awards, so.
I think you could just put that equals also test points. That's exactly. Words. I just. Mistake. We. Time on the exam is important. Just like click is.
Yeah.
You have to pick. No, you're putting.
Yeah, just like.
For five. Four. Why doesn't it?
You sort of know the more. And you have an association.
Like, yeah. Like, I just want to. Does it make sense? Maybe like. We can have two values that special.
Alright,
So like.
Oh, that's your job.
You literally. Yes, you do.
Yeah. sounds good.
Wait, I thought you were not.
Well, you did that. And then-
Wow. Because it's not easy. Yeah. Usually our alternative hypothesis is like, it's not.
Yeah, I can that. Enter the
I can't tell you exam scores.
Exams time scores.
I feel like it's just not like, yeah, but like, I do.
What's it?
Something more time than studying.
This is the one that I spent on the exam.
Oh,
You can just have a piece like.
that makes sense. Sometimes you spend more time because you're like in the zone. Sure. Or well, you spend more time. You don't understand. Yeah. Oh, that's fine.
I don't know.
Just know that.
Couple options.
Amount of time spent on the exam could, or like the variables.
One possible slopes.
But to understand it, or wait, all possible slopes from the exam score, yeah.
Yeah, the shuttle cost scores. Over 2 out of 4 helps us slope. And then there's a slope. No.
You guys did it?
Because it's because it's a shape reasons that it's within the gray. You might as probably find the slope is one.
That is as extreme as.
It's negative 0.0. 0 max. Define slope that is that.
Yeah, the difference in where you are. Like, yes.
Beyond. He was assuming that the whole.
Or the null hypothesis. What'd you guys?
Tie. That's what you got.
0.5120.
Remember, two is gonna be.
Oh, and that.
Either way, they're both probably.
What did you?
There.
Were they part of it? That's so nice.
But still. Well, it's still not.
So not strong enough. So we got. There's not enough.
Zero.
Evidence that there is correlation.
There's an association.
There's not evidence that there's an association. Or not evidence. Also not evidence that there's no association.
All right. We are out of time for today. Very nice job today, and thank you for your patience with my printing issues. I will see you tomorrow, and we will talk about this as well as theory-based linear regression. I'll see you then.
What's that?
bet you always love me.